Bismillahirrahmanirrahim. Assalamu alaikum. Hello everybody. So let's discuss now what do we mean by Brownian motion. Brownian motion. So a stochastic process, let me denote it by B of t comma omega is said to be Brownian motion if it satisfies following conditions. So the condition number 1 is probability of being zero at time 0 is 100%. In other words, you can say that this process is 0 at time 0, or sometimes people write it b of 0 is 0, or in some notations sometimes we can also say that b naught is 0 when we represent this Brownian is this in place of this. So the first condition that is imposed is that this stochastic process is 0 at time 0. So initially it's 0. The Brownian motion is 0 at initial time. What's the second condition? So second condition is, it says that for any time interval or any two time values s and t, s less than t and s greater than equal to t, the random variable, the random variable, which random variable? This random variable, let me write this way, beta of t minus beta of s. This random variable is normally distributed with mean 0. In other words, we can say that expectation of beta of t minus beta of s is 0, right? So with mean 0 and variance t minus s, or you can say that the variance of this process, or this random variable beta of t minus beta of s is equal to t minus s. Also the probability distribution function that this increment follows, in other words this beta of t minus beta of s follows, is given by this. So the probability of a less than equal to beta of t minus beta of s being less than equal to b is equal to, so it's going to be the normal probability distribution 2 pi t minus s a till b. So it's the exponential of x square minus x square over 2 times of t minus s dx. So this is the probability distribution function that it follows. So these are two conditions. There are also two more conditions. Like the third condition is The third condition says that beta of t comma w, or the Brownian motion, has independent increments. Independent increments. What does this mean? This means that if you pick up, time values t1 less than t2 less than t3 blah 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 less than tn, then these random variables beta of t1, beta of t2, minus beta of t1, you one can write beta of t1 minus beta of 0, or maybe beta of t1 and then beta of t2 minus beta of t1, comma beta of t3 minus beta of t2. So this sequence goes on till beta of tn minus beta of tn minus 1. So the meaning of independent increments is, if you consider time values t1 less than t2 and till tn, then you consider these increments which are beta of t1 minus beta of 0, then beta of t2 minus beta of t1, beta of t3 minus beta of t2, then beta of t4 minus beta of t3, so on and so forth, like beta of tn minus beta of tn minus 1. So these are basically independent. These are independent. So the meaning of independent increments is here. So this is the meaning of beta of t having independent increments. Then there is one last condition also, which is condition number 4, and it says that almost all paths of Brownian motion are continuous functions, i.e. we can say that probability of this, for every t, this continuity is 100%. So all paths are continuous. So these are 4 conditions that we need to have in Brownian motion. So Brownian motion is a stochastic process which satisfies these 4 conditions. And the next example, we're gonna try to see example of Brownian motion, and that's going to be the random walk, and then we will move on defining some more quantities. Allah Hafiz.